Okay, so we continue and we solve the last exercise. Excuse me. Yeah. What is this? No, there aren't any section here. Okay. So yes, so the last exercise, let's say that A is the matrix of a linear mapping. So A is 1, 2. So we say that the matrix A given by 1, 2, 0, 1, 2, 0, and 0, 0, 0 is the matrix of a linear mapping. Determine. So this says that find the basis of the nuclear, means it's called in English it's called the kernel, the kernel of F, the kernel of F, and say if the linear mapping is injective or not. So we need to find the basis for the kernel and say if the linear mapping is injective or not. So let me, what did I take here? Okay, so I repeat that the linear mapping is injective, okay, if and only if the dimension of the kernel is equal to 0. Okay, so if the dimension of the kernel is 0, this is equivalent to say that the linear mapping is injective. How do you find the dimension of the kernel? The dimension of the kernel is equal to to get the dimension of the kernel is actually equal to okay, just to be the dimension of the kernel, how can I, so in fact look, is the number to be let's say to be less, is the number of column, the dimension of the kernel is the number of column of the matrix, okay, minus the rank of the of A. Okay, the dimension of the this is, if you want to be, just to be, as I don't want to do all the theory now of the linear mappings, but the dimension of the kernel is the number of the column of the matrix minus the rank of A. Is that clear? So how much is it in this case? The dimension of the kernel will be number of column 3 minus the rank of A. What the rank of this matrix? We already know that this matrix, if you reduce it, it gives you like this. So the rank is 1, and thus the dimension of the kernel is 2. 2 is not 0, so the matrix is not the F is not inject. The linear mapping is not injective. We saw that the linear mapping is injective if and only if the dimension of the kernel is 0. In this case, we saw the dimension of the kernel is 2, so the linear mapping is not injective. Okay? Yes, in fact, the kernel are all the kernel of the linear mapping are all the vector that linear mapping map to 0. Is that clear? Yes, the kernel is the span of all the vectors that goes to 0. So now to find the kernel, you solve the system. To find the kernel of a linear mapping, In fact, you want to find the vector that the linear mapping map to Z. Is that clear? So to find the kernel, you need to solve this system. But we already solved this system. Yes or not? And you remember we solved it for the eigenvalues, and we saw that the solutions was linear of 2, 1, 0, and 0, 0. Yes or not? In fact, this is the kernel. No, the third one was for lambda equal to. In fact, the kernel should be linear of 2 vector because it is dimension 2. So the curve. No, not any. The kernel came from the solution of this system, and the solution of this system is this. The other one was the solution of another system. Is that clear? So it will get linear of 2, 1, 0 and 0, 0, 1. This is the kernel of this linear mapping. Is that clear? Nice. As this end up with this section also, and we will I will send you the stuff on YouTube. Okay.